Everything related to boards, nothing beyond that. Right? If it is not there in your board, I will not. I think this is MTG, right? This is your board's weightage. What is this? 8.1, 8.2, 8.3, 8.4, 8.7. Hmm? From 8.1 to 8.10. Because this chapter is having 10 parts according to your boards. Based upon nomenclature, aldehyde ketones preparation, physical properties, chemical properties, uses, nomenclature and structure of carbonyl compounds, methods of preparation of carboxylic acids. This is about aldehyde ketones. That 8.6 is about carboxylic acids and derivatives. Then physical properties, chemical properties, uses. So from 8.1 to 8.10, see the weightage. So most of the cases, they are giving framing questions from 8.4 and 8.9. Correct? Either MCQ or very short or SA1, SA2. Right? Short answers or long answers. Mostly they are framing questions from 8.4 and 8.9. What is 8.4? Chemical reactions of aldehydes and ketones. 8.9 is chemical reactions of carboxylic acids derivatives. So for your boards, important thing is chemical properties of carbonyl compounds is very important. That's all. Correct? Online, do the screen is properly visible?
Yes, sir.
Yes, sir.
So let me maximize. Now, this is complete summary of your NCRT board textbook, right? So Friday, Saturday, Sunday, we will discuss as usual. Our regular classes, we will discuss as usual. Only Thursday classes, we will do things related to your boards, right? Of course, this will help you there also. We will understand which is important, which is not less important, right? Now, just for 2 minutes, go through it. What is present in it? Just read it for 2 minutes. One more thing. I need to convey this. While you are preparing or while you are studying anything, always follow this rule. We call this as OK 4 R's. R, 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 R. R1, R2, R3, R4. This is the principle. In order to memorize or remember things. O means overview. K is key ideas. R1 is read. Right? This is overview. Key ideas. Read. Then recall. Then what we call it as practice. What we call it as. Huh? Then what about the last hour? Hmm? Revision means over. Everything is over. Just a moment. What is that? There is this one principle, man. Okay, 4R principle. Just a moment. Let me check in internet. Oh. Is of the carbon chain, right? So is it aldehyde or not? This one. Oh, you are not able to see this one. It is aldehyde. Now, what about this one? CH3, CO, CH3. What about this one? Ketone. This is middle of the carbon chain. Do it also follow this same formula or not? Check. C3 hydrogens, 6 oxygen. Oh,
Sir, your screen is not shared, sir.
hooray, online. Screen
Yes,
is
sir.
always
Can't see your screen, sir.
shared it, man. Just a moment. Just a moment. Stop sharing. Again, I'm sharing. Continue. Start. Share. Now, sir.
No, sir.
No, sir. Your face is visible, sir.
Why? Continue. Start. Selected. Noise cancellation. Everything is okay. Settings are okay. Continue. Entire screen. Start. Continue. Single app. Start. Okay. Let me share again. One more. Now? Now also not visible. Huh?
Yes, sir.
I will do one thing. I will rejoin. Join. Join. Join here too. Continue. Start. One more. Now?
Yes, sir. Now it is visible, sir.
Ah, right. Now, whether aldehyde ketone both are obeying same formula or not, CnH2nO, right? So first point is done, general formula. This condition is done. No, I am going to next statement. Nomenclature. Already you know the nomenclature. Aldehydes nomenclature should end with Al, ketones with ONE, carboxylic acids with OIC acid. Right? I am repeating the same. If it is aldehyde, suffix will be Al. If it is a ketone, suffix will be ONE. If it is acid, OIC acid. Correct? Huh? What is the name of this one? What is its name? Ah, yes. Propanol. Then what about this one? What is the name of it? 1, 2, 3, 4. Ketone. Butane, 2-one. What about this one? What is it? Propanoic acid. Then what about this one? CH3, CH2, C double bond O, CH2, CH2, CH3. What type of functional group is this? Ester, na? This is ester. Ester should be named as O8. Right? Now give numbering to it. If a functional group possesses carbon, I have to start numbering from that carbon. Right? So functional group is having carbon in it. So I need to start numbering from there. So 1, 2, 3 means this is branch. What is that branch? Propyl. So propyl, propanoate. Propyl is the substituent. So name of this is propyl propanoate. Any questions, sir? Online? Respond. Any questions in it?
Sir,
Yes, sir.
sir, we are starting from the carbon having double bond O, sir, and then we are going for 3 carbons, so it is propan, sir.
Yes.
And propyl group is attached, so we are calling as
correct. So name of the esters always should be alkyl alkanoate. Right? This alkyl will be, name of this alkyl will be which got connected to C double bond O. This alkyl is which got connected to oxygen. So towards oxygen which got connected, propyl is connected. So propyl, this is propyl. So let me take one more. Now give the name of this one. How many carbons in the principal chain now? Is it ester or not? Right? No. Only one. What I told you, always you need to start numbering from the carbon which is present in the functional group. So only one carbon possessing functional group. Right? Then give the name of it. Ethyl methanoate. Ethyl methanoate. Clear, na? Now I am taking one more. What is the name of this one? 1, 2, 3. Can I call it as acidic halide? All these are carboxylic acid derivatives. What we call them as acid derivatives. Acid derivatives. Acid derivatives means which are obtained from acids. This is carboxylic acid, right? If a carboxylic acid allowed to react with alcohol, alcohol means like this, right? From here, if I remove H2O, what you will get? If I remove H2O, what happened? It becomes a CO, O. That side carbon chain, this side carbon chain. What do we call that as? CO, O. That side carbon chain, this side carbon chain. What do we call it as? Ester. Right? So acid plus alcohols give esters. Yes. So this is acid. That's why you call it as oic acid. Oic acid plus OL. Oic acid reacts with OL. Correct? Alcohol plus acid gives OA8. Correct? Yes, sir. Any questions in it? So, do ester is obtained from carboxylic acid or not? That's why it is called acid derivative. Now I am taking one more. This is carboxylic acid. Allowed to react with PCl3 or PCl5 or SOCl2 or SO2Cl2. What happened? All these reagents will replace OH group with halogen. If it is PBr3, OH is replaced with Br. So only this group will be replaced. So in all these cases, what you are getting? What do you get? COCl, acid halide. So oic acid with any halide derivatives forms acid halide. So what do we call it as? Oil halide. Oil halide. For example, CH3COCl. Then what it is? 1, 2, 2 carbon chain. So name is ethanoyl chloride. Right, this O is important. If that O is not there, then it is ethanyl chloride, means ethane, chlorine should be present. Then it becomes alkyl halide. Correct or not? Alkyl chloride. Ethanyl chloride means alkyl chloride. Here O is important. Ethanoyl chloride. Any questions? Is it acid derivative or not? Now I am taking one more. This is oic acid. Reacted with another oic acid. Both are oic acids only. Now I am removing H2O. Then what do we call it as? Anhydride. Anhydride means water removed, right? So what we call it as acid anhydride. This is acid anhydride. Can I write that as C double bond O, O, C double bond O group, correct? No. Example. CH3, C double bond O, O, again C double bond O, CH2, CH3. Now observe how to name it. It is not symmetrical. I have not taken both carboxylic acids same. If both carboxylic acids are same, no problem. Then I will call it as that respective anhydride. Right? Now that side carbon chain is different. This side carbon chain is different. I have to start numbering always from function group with carbon. So I need to start numbering either this or this. So according to rules, longest carbon chain should be named, na? So how to name now? 1, 2, 3. Correct? Na? Now tell me, what is the name of it? Can I call it as alkanoyl alkanoate? If I consider this as substituent, this group as a substituent, then it is like ester only. If I consider this total thing as substituent, then it is like ester only. If it is alkyl alkanoate, ester. If it is alkanoyl alkanoate, anhydride. Right? So name of this ethanol. Ethane and oxygen is there. So ethanol. If it is only CH3, CH2, then it is ethyl. CH3, CO means ethanol. Correct? Ethanol. Then remaining propanoate. Any questions online? Do you have any questions in it?
No, sir.
Right. This is about acid anhydride. So we have seen nomenclature of esters, acid halides, and this is acid anhydrides. Now I am taking one more. Acids allowed to react with amines. Acids with alcohols form esters. Acids with amines. This is oic acid, this is amine. So here also remove H2O. Here also remove H2O. Then we call it as amide. We call it as amide. C double bond O NH. From here H, from here OH is one. So amide. C double bond O NH. Now what is the name of it? For example, I have taken CH3, CH2, C double bond O NH, CH3. Give the name of it. So I need to start numbering from here or not? 1, 2, 3. Now, how to name it? First, I need to name the substituent. This substituent is present over nitrogen. So that's why I call it as N-methyl. Are you able to understand why I am writing it as N-methyl? Because that methyl group is present over N. So N-methyl propanamide. Any questions, sir? Is it clear? Respond online. You need to respond.
Yes, sir. Yes, sir.
Yes, sir.
No. I am taking one more example. CH3, CH2, C double bond O, ENH2. Is it amide function group or not? Amide. So give name of it. I need to start numbering from here. 1, 2, 3. Is there any branch over nitrogen? No. So no need to mention. So simply name it. Propanamide. Done? No, I am taking again. CH3, CH, CH3, C double bond O, NH2. Now give the name of it. 1, 2, 3. This is also amide only. But you have branch where it is on second carbon. So can I call it as 2-methyl propanamide? Respond. Correct? So 2-methyl propanamide. Now observe the above case now. Observe this case. Are you able to understand why I mentioned it as N-methyl propanamide? Methyl is the substituent, but that methyl substituent is present over nitrogen. That's why I mentioned it. N-methyl propanamide. Here it is 2-methyl propanamide. Is it clear? Respond.
Yes, sir. Sir.
Yes, sir. Parthasarathi. Understood or not?
Sir.
Yes. Shall I go with another example? Because this methyl group is present over nitrogen. That's why I call it as N-methyl. Remaining is propanamide. For example, see this one. CH3, CH2, N, CH3, CH3. Now give the name of it. Is it amine compound or not? We call it as a tertiary amine. Yes or no? Correct? It is tertiary amine because nitrogen connected to 3 carbons. So tertiary. If nitrogen connected to 1 carbon, primary amine. Nitrogen connected to 2 carbons, secondary amine. Connected to 3 carbons, so tertiary amine. Right? So this is connected to this side 1 carbon, second carbon, third carbon. So tertiary. Right? Now, in that amine, branches are there. So first I have to give numbering. Longest carbon chain should be given with numbering. So it is ethane. I call it as ethanamine, having branches. Where that branches are? On nitrogen. So what I have to name it as? Yes, over. N comma N. Are 2 times, na? So N comma N dimethyl. Correct? N comma N dimethyl ethanamine. Is it clear? Understood now for everyone?
Yes, sir.
Right. So we are done with nomenclature. Shall I go to next concept? This part is also over. Right. Common names of most aldehydes are derived from the common names of corresponding carboxylic acids. Right. Acetic acid, acetaldehyde. Propanoic acid, propanaldehyde. Butyric acid, butyraldehyde. Correct or not? All aldehyde names are obtained from respective acids. Correct. Acrylic acid, acrylaldehyde. Cinnamic acid, cinnamaldehyde. Salicylic acid, salicylaldehyde. So just I will show few more. I will show few more and I will come back. For example, see this one. On benzene ring, if we have carboxylic acid and also OH group, then what we call it as salicylic acid. This is present at ortho position. That's why it is called ortho salicylic acid. Instead of acid, if I get aldehyde group, I am taking aldehyde here and OH here. Then what we call it as salicylaldehyde. This is salicylic acid. Then I call it as salicylaldehyde. So this is also ortho only. So what we call it as ortho salicylaldehyde. That's what they are saying. What they are mentioning here. The common names of most aldehydes are derived from common names of corresponding carboxylic acids. Correct or not? Whatever the acid is there, from there acid only we got aldehyde names also. Any questions in it? Right? So by replacing oic acid with aldehyde word, and a salicylic acid, salicylaldehyde means ic acid name is replaced by aldehyde. Correct? This ic acid name is replaced with aldehyde. That's what they are saying. Correct only, no? That too only in common names, not in IUPAC names. Right? No questions in that. Now, what is the next statement? IUPAC names of open chain aliphatic aldehydes and ketones are derived from the names of corresponding alkanes by replacing last E with AL RONE, correct. Done that statement also. Structure. Carbon atom of carbonyl group is sp2 hybridized and forms 3 sigma bonds and 1 pi bond with oxygen atom. Carbonyl carbon with 3 carbon atoms attached to it lie in a small same plane with bond angle of 120. Some nonsense. See what they are saying. I am coming to this. Let me to go with aldehyde or acid, whatever may be the functional group. Let me take this aldehyde functional group. Is it aldehyde functional group or not? Right? So let me take CH3 group. Here this carbon is having double bond. So what is the hybridization of it? sp2. sp2 means what is the geometry? Trigonal planar means this oxygen, this hydrogen, and this carbon. All these three will be in same plane. Correct? Now I am taking one more. CH3, CO, CH3. What is the hybridization of this carbon? That is also sp2. Then also its geometry is trigonal planar. Means this carbon, this carbon, this oxygen, this carbon, all will be in same plane. Remaining these 3 hydrogens, those 3 hydrogens, they are in different plane because hybridization of this carbon is, these 2 carbons hybridization is sp3. That's why they will not be in plane. As this carbon is in sp2 hybridized, so the carbons which attach to it will be in same plane. Right? Now I am taking carboxylic acids. CH3, CO, OH. Is it carboxylic acid or not? Now here also, what is hybridization of this carbon? Again sp2 because it is also double bonded with oxygen. Now, along with this carbon, this oxygen, this carbon, this oxygen will be in same plane again. Means in aldehydes or ketones or carboxylic acids or its derivatives, wherever it is, carbon which is double bonded to oxygen will be sp2 hybridized. The other atoms which connected to it will be on in same plane. That's what they are saying. Now read the statement what they are saying. The carbon atom of carbonyl group means C double bond O group is called carbonyl group. This group is called carbonyl group. This C double bond O group, we call this as carbonyl group. Do this carbonyl group is present in aldehydes, ketones, acids, acid halides, esters, acid anhydrides, amides. In all these cases, that C double bond O group is common. Na? That's why what we call this chapter name as carbonyl compounds. Of course, in your NCERT, they call it as aldehydes, ketones, carboxylic acid chapter. But in all these cases, what is common? C double bond O group is common. That's why we call this chapter as carbonyl compounds. Clear? Right? Any questions, sir, about that statement? If it is sp2 hybridized, what should be bond angle? 120. Geometry, trigonal. Coplanar means everything is in same plane. That's why it is called coplanar, right? Any questions about this point? Clear now this point also. Now come to next one. Oxidation of alcohols. I cannot change the size. Okay, leave it, no issue. Next is editing. What they are talking about? Oxidation of alcohols. Now see this. What do you mean by oxidation? We already know oxidation means addition of oxygen or removal of hydrogen, right? Removal of H or addition of O, or both. By removing H, if I add O, then also oxidation. Without removing H, if I add O, that also oxidation. Without adding O, if I remove H also, oxidation. Or loss of electrons. If I remove electrons also, oxidation. Right? For example, if I convert CH3 bond CH3 ethane to CH2 double bond CH2, is it oxidation or not? Correct? No. I am taking CH3 CH2OH converted to CH3 C double bond OH. What I have done? I removed one H here, one H there. One hydrogen I removed from carbon, one hydrogen I removed from oxygen. Then also removal of hydrogen only, oxidation. Correct? Now, CH2 double bond CH2 converted to CH2 CH2O. Is it oxidation or not? Addition of oxygen, so oxidation. Correct? No? What I have to do? I need to add both. So CH3 CH2OH I converted to CH3 C double bond OH. Now what I have done? Two hydrogens I removed, one oxygen I added. So this is also oxidation. Removal of hydrogen as well as addition of oxygen. Correct? Oxidation. Any questions, sir? Removal of hydrogen, addition of oxygen, or loss of electrons. If electrons are lost, you will get cations. Then also it is oxidation. Nothing wrong. Any questions? Response are online.
No, sir.
No.
No doubt, sir.
So what first side heading they give? Oxidation of alcohols means I have to take only alcohols. Means in this condition, what I have to do? I have to go for either this condition or this condition. Right? So for that, what I am doing? Reagents for oxidation, reagents I am using is PCC, pyridinium chlorochromate, PDC, pyridinium dichromate, copper. These are all mild oxidizing agents. These are all mild oxidizing agents. Pyridinium chromyl chloride or chlorochromate, pyridinium dichromate, copper. Now, if it is mild oxidizing agent, if I am taking primary alcohol, for example, I am taking CH3 CH2OH. Is it primary alcohol or not? With mild oxidizing agent, only removal of hydrogen happens. Means what you will get? CH3, remove one H here, remove one H here. So you'll get double bond O. So primary alcohols are converted to aldehydes. Right? No. If it is secondary alcohol, CH3, CHOH, CH3. Is it secondary carbon or not? Carbon which connected to two carbons is called secondary carbon. Over that, if you have OH, secondary alcohol. Right? Now, do the same thing. Now what you got? ketones. Now, if it is a tertiary alcohol, no reaction. If it is mild oxidizing agent, no reaction. With the PCC or PDC, no reaction. Only one special case. If it is copper on heating, right? Instead of dehydrogenation, it will undergo dehydration. What do you mean by dehydrogenation? Removal of hydrogens is called dehydrogenation. Is it removal of hydrogens here or not? Right? So, removal of two hydrogens is called as dehydrogenation. Right? If it is removal of a hydrogen and also OH group, both, means in total what has lost? Water is lost. So we call it as dehydration. Observe the difference between dehydrogenation and dehydration. Observe the difference between both. Clear? So what happens here? Dehydration happens, not dehydrogenation. Dehydration means both hydrogens lost, oxygen also lost. Right? So if I remove OH group and H, what do you get? CH3 carbon, CH3 double bond, CH2. So here what happened? Dehydration happened. Except copper, in remaining cases, no reaction. Only in case of copper, dehydration happens and you will get alkenes. That too with a tertiary. If it is a primary, secondary, same. Whether it is PCC or PDC or copper, same. Clear? Any questions? Now come to this example, what they gave. Understood about that example? What they gave? Oxidation of alcohols. Primary alcohols with K2Cr2O7, dilute H2SO4, gave aldehyde. Now again, secondary alcohol with K2Cr2O7, dilute H2SO4, gave ketone. Below that, in presence of catalyst, primary alcohol with copper, aldehyde. Secondary alcohol with copper, ketone. If it is a tertiary alcohol with copper, alkene. Is it clear? Respond. Any questions in that? Online, do you have any questions?
No, sir.
Means we are done this point as well as this point. Right? Now, let me.
Sir,
Yes, sir.
sir, can you show me the second example that you gave?
Here.
A little bit above, sir, for removal of hydrogen.
Yes.
Sir, the second one, are they what we call as epoxides, sir?
Alkene to form epoxides. Yes.
Yes, sir. So they are epoxides.
Correct.
Yes, sir.
This is called epoxy. He's talking about this one. This is called epoxide. Right? Any questions? Right. Now, here one small change I have to show. If I am taking CrO3, chromic oxide, chromium is in +6 state or not? If any element is in its highest oxidation number, then it is a good oxidizing agent. Now tell me H2SO4, K2Cr2O7, KMnO4, HiO4. All these are good oxidizing agents. Clear? If any element is in its highest oxidation state, then it is a good oxidizing agent. So CrO3, good oxidizing agent. If this CrO3 in presence of water and pyridine, then it is a mild oxidizing agent. If the same CrO3 in presence of sulfuric acid, then it is a strong oxidizing agent. We call this as Jones reagent. Right? Or we also call it as Collins-Jones reagent. Okay, better. I told you one thing, na? Whatever is present in NCRT, that only. We will not go anything beyond that. Right? No need. Don't bother about it. It is not there, so we will not discuss. Right? No. As they mentioned this one, K2Cr2O7 in presence of H2SO4. That's why we will discuss about this only. Right? Or KMnO4 in presence of H2SO4. Right? Only we will discuss about that. We will not discuss anything beyond that. Right? So I am discussing about only those. Note. If it is KMnO4 in presence of base, we call it as Bayer's reagent. KMnO4 in presence of base, we call it as Bayer's reagent. Right? It is also a good oxidizing agent. KMnO4 in presence of H plus, also good oxidizing agent. KMnO4 in presence of water, it is even stronger oxidizing agent compared to both. The same thing you studied in redox reactions, N factor. KMnO4 in acidic medium, N factor is 5. KMnO4 in basic medium, N factor is 1. KMnO4 in neutral medium or what we call it as slightly alkaline. Right? In that case, or mild alkaline medium. There, what you get? N factor as 3. See this. Let me show that. Can I write KMnO4 as MnO4 minus? If it is acidic medium, it converts to Mn plus 2. The same KMnO4, if it is basic medium, then it will convert into MnO4 2 minus. Same KMnO4, if it is neutral medium or slightly alkaline medium, sir, yes, sir. Customer, sir. It's కూడా కష్టమేమో సార్ కష్టం అస్సలు ఓకే నేను రేపు పంపిస్తాను క్లాస్లో ఉన్నాను సరే సార్ slightly alkaline or neutral. In that, it will convert to MnO2. Here, manganese is in plus 7, plus 7, plus 7. Here, plus 2. Here it is plus 6. Here it is plus 4. What is change in oxidation number? 7 to 2 means 5. Here, 7 to 6 means 1. Here, 7 to 4 means 3. Right? Where KMnO4 acts as very strong oxidizing agent means compared to any medium, it acts as strong oxidizing agent in neutral medium. Right? Best example. Iodides are converted to I2 in every medium, but in neutral medium, iodides are converted to iodates, IO3 minus. Is it clear? I am writing again. In every medium, I minus will convert to I2. If I use KMnO4 in acidic medium or KMnO4 in basic medium. If it is KMnO4 in neutral medium, it will convert to IO3 minus. Here iodine converting from -1 to 0. Here iodine converting from -1 to +5. Is it clear? Now tell me which is better oxidizing agent. Understood or not? Clear? So we will not discuss about or we'll do one thing. Okay, let it be. Let it be. Clear? Any questions? Respond, sir. Online, respond.
It's
Same way,
sir.
K2Cr2O7 in acidic medium, K2Cr2O7 in basic medium. In every medium, K2Cr2O7 N factor remains as 6 only. It will not change. But K14, based upon medium, its N factor will change. But K2Cr2O7 in every medium, it remains as same. Right? Clear now? So now I am taking again note. If the same KMnO4 in presence of H plus followed by heating, if I don't heat, it is something. If I heat, it is something. Right? First, let me discuss about if I don't heat. Or, yes, sir. Parthasarthi.
sir, one doubt, sir.
Yes, sir.
Sir, you have taken KMN of a neutral medium, sir. Their N factor is 2. But in basic medium, their N factor is 1. Sir,
Correct.
you are arranging the KMN of oxidizing power based on N factor, no, sir.
Again, go again.
Sir, I'm asking that you are arranging KMN of oxidizing power based on N factor.
Not only that, based upon reduction potential. That reduction potential values I have not given. Okay.
Okay, sir. My doubt
The
is that N
electrochemistry
factor
you have one
for
table,
basic
right?
medium is 1, no, sir.
No, that's
Yes,
why
sir.
not based upon N factor. I gave that oxidation potential based upon E0 values. Okay.
Yes, sir.
Right.
Understood, sir.
Now, KMnO4 in terms of H plus or K2Cr2O7 in terms of H plus. Generally, these two are considered as a strong oxidizing agents. Sir, why you are mentioning them specially? The reason is this reaction they have shown that is wrong. Reason what they have done. K2Cr2O7 in terms of acid, na, it is a good oxidizing agent. So reaction will not stop at aldehyde. That aldehyde will react further to form carboxylic acid. Are you able to understand? But they have taken only up to here. They have restricted the reaction. In reality, we cannot restrict. Right? But in our NCRT, if they give this, we will write that down. But in reality, they are good oxidizing agents. That's why I'm mentioning them separately. Otherwise, I will not disturb it. Okay. So these are good oxidizing agents. That's why if it is primary alcohol, will you understand if I write like this? They will convert to aldehydes, and aldehydes will convert to carboxylic acid. If it is a secondary alcohol, it will convert to ketone. Further will not happen. Yes, sir. Someone saying something. Respond. Now coming to this. If it is a tertiary alcohol, no reaction. Right? If it is primary, it will convert to aldehyde, aldehyde to carboxylic acid. If it is secondary, goes to aldehyde, ketone. If it is tertiary, no reaction. The same thing, for example, if you take KMnO4 in presence of acid followed by heating, then carbon-carbon bond also will break. Are you able to understand? C double bond O, C bond, if exist, this bond also will break. If you heat, if I don't heat, it will not break. Example I'm taking. Listen. I'm taking CH3, CH2, CH, OH, CH3. Is it primary alcohol or secondary or tertiary? Is it primary or secondary or tertiary? Secondary. It is secondary alcohol. So with KMnO4 in presence of H plus. Now tell me what should happen. Aldehyde or ketone? Ketone. CH3, CH2, C double bond O, CH3, ketone. I'm taking same again. KMnO4 in presence of H plus followed by heating. Now I'm heating. Then what happened? Whatever the product this is obtained, after getting that, what should happen? C double bond O, C bond will break. So if I write as CH2 like this, that bond also break. Now, which side it has to break? Whether it has to break that side or this side, or both sides you have C double bond, right? So this will break according to Popov rule. That will break according to Popov's rule. What is Popov's rule means? This C double bond O group is there now, that always go to lowest chain. Right? When that bond breaks, this C double bond O group is there now, that should go to lower chain. Means, tell me whether it has to break this side or this side. So product will be, so let me write this one as it is. First I will write this one. So C double bond O group should go to smaller chain, means it has to break here. Correct? So based upon Popov rule. So now tell me what should be the product. What should be the product? This will convert into acid, that also converts into acid. This will convert to acid, that also converts to acid. So I will get 2 moles of acetic acid. I will get 2 moles of acetic acid. Any questions in it? Clear? Right? Done or not? So everything related to this point is done. Oxidation of alcohols, done or not? Right? Now coming to next point. Response, sir, online. Any questions?
No, sir.
Next one, sir. Reductive ozonolysis of alkenes. Next topic. Reductive ozonolysis of alkenes. Now I am coming back. What do you mean by reductive ozonolysis? In case of ozonolysis, reagent, ozone, in presence of any solvent, maybe carbon tetrachloride, or maybe chloroform, or maybe CH2Cl2, any solvent. So I am taking CH2Cl2 as a solvent. Then I need to add zinc in presence of water. If I don't add zinc, then it is called oxidative ozonolysis. If I add zinc, then it is called reductive ozonolysis. Is it clear? If zinc is not there, then it is called oxidative ozonolysis. I am taking O3, CH2Cl2, followed by hydrolysis. Then I call this as, this is oxidative ozonolysis. This is called reductive ozonolysis. Any questions? Right? No. First, we are talking about reductive ozone analysis. Any alkene, I am taking CH3, CH double bond, CH2 alkene, allowed to react with O3 in presence of CH2, Cl. First, ozone will go on attack. So we'll get that pi bond is gone. So that ozone got connected at that pi bond. Then it will rearrange by breaking another carbon-carbon bond. Right? Now, in presence of zinc and H2O, or in presence of H2O. If a zinc is present, if a zinc is absent, this is called oxidative ozone analysis, correct? This is called reductive ozone analysis. Then break this one like this. If it is a reductive ozone analysis, this left oxygen is taken by zinc to form zinc oxide. If that oxygen is gone, what is left? This carbon is having O, that carbon is also having O, so product will be. Yes, correct. CH3, CHO. That side also CH2, C double bond here, correct? CH2 double bond. Correct? Reductive ozone analysis. If it is oxidative ozone analysis, aldehyde will be converted to acid, carboxylic acid. So product will be CH3COOH. This also will convert to acid. Is it clear? Both are obtained as acids. That is called oxidative ozone analysis. If a zinc is present, reductive. Otherwise, oxide. Right? Instead of this, I can also use this one. Ozone CH2Cl2 in presence of dimethyl sulfide also I can use. Instead of zinc and water, I can use dimethyl sulfide as also reductive ozone analysis reaction. Right? Either I use zinc in presence of water or I can use dimethyl sulfide. This also reductive. Any questions? Clear or not? One more point I will write. Here we are getting formic acid now. In the same way, if I am getting formic acid, here also I should get carboxylic acid, right? Alcohols in presence of KMN4, you are getting carboxylic acid. Here also, if you get formic acid, you will get carbon dioxide. For example, say this. CH3OH methanol allowed to react with KMNO4 in presence of H plus. Now tell me what should be the product. Only one carbon. What should happen? Or if you have 1, 2, 3, 4, this carbon converted into double bond O, ketone. If it is at the end, primary alcohol, you will get aldehyde. Aldehyde will convert to acid. That acid should possess how many carbons? One carbon only. Correct or not? So product must be HCOOH. What do you got? Formic acid. All carboxylic acids are stable in presence of KMNO4 except formic acid. Are you able to understand? All carboxylic acids are stable in KMNO4 or K2CR2O7. Means all are stable in strong oxidizing agents except formic acid. Formic acid in presence of strong oxidizing agents will undergo oxidation further to form carbon dioxide and water. Except this, in remaining all cases, reaction will stop at carboxylic acid. Only in case of formic acid, it will convert further to carbon dioxide. Any questions? Now, any questions about ozone analysis? Now see this one, whether this is done or not. Are you able to understand why they gave zinc oxide? If a zinc is present, that zinc will take that oxide to form zinc oxide, and remaining both chains will convert to aldehydes. Done. Next one, sir. Rosenman reduction. Next one, Rosenman reduction. Now observe this. Hydrogen in presence of pelladized carbon. Hydrogen in presence of pelladized carbon. If I take barium sulfate, quinoline, or sulfur, then it is called Lindlar's catalyst. Here, what we have taken? Only sulfur, pelladized hydrogen in presence of pelladized carbon, barium sulfate, sulfur, right? Just a moment. I will show the difference between what is it? Rosenman and Lindlar's, right? Lindlar's catalyst. Observe, sir, what they have given. Lindlar's catalyst. A popular poisoned catalyst is a mixture of palladium, calcium carbonate, and lead. A mixture known as Lindlar's catalyst. In addition to amines, in addition, amines such as, means in above case, instead of palladium, calcium carbonate, or lead acetate, in addition to that, we can add amines such as quinoline. This one, quinoline, are often added to render the catalyst less effective. An equivalent reagent to Lindlar's catalyst is palladium, barium sulfate with quinoline. So quinoline also present above case. Palladium, calcium carbonate, and lead acetate. We call that as Lindlar catalyst. Right? Instead of that, we can also use palladium, barium sulfate, and quinoline. Clear? Response, sir.
Sir, your screen is not visible, sir.
Just a moment. Hello. Yes, madam. Madam, in class, madam. Right, madam. Right, madam. They are not able to see. Okay, I will do here only. I will write hydrogen, palladized carbon. When you are writing palladium, no need to write H2 also. Reason? Hydrogen occlude over the surface of palladium. What do you mean by occlusion? Gas adsorption of gases on the surface of metals is called occlusion. Gases will stick to the surface of metals, right? And they go into the metal also and occupy the gaps inside metal atoms. We call that as absorption. If they stick to the surface, adsorption. If adsorption and absorption both occur simultaneously, then it is called sorption. Sorption of gases over metals is called occlusion. So hydrogen gas generally occlude over palladium catalyst. Palladium means whenever I am taking palladium, no need to write H2. Just if you write PD, automatically H2 is also there. Is it clear? So here I have written it as H2 palladium, palladized carbon, right? Clear? Over the surface of calcium carbonate or lead acetate. Okay, va? Or I can take hydrogen presence of pellucidized carbon in presence of barium sulfate and quinoline. What is quinoline? This is called quinoline. Both are same. We call this reagent as Lindlar's catalyst. This is called Lindlar's catalyst. Okay, well, what is specialty about Lindlar's catalyst means it shows syn hydrogenation, addition of H2 from same side. That is called syn hydrogenation. For example, if I take CH3, C triple bond, CCH3 in presence of hydrogen, pellucidized carbon, barium sulfate or sulfur in presence of quinoline. Now what should happen? Both hydrogens should be added over same side, right? But complete reduction will not occur, only partial. That's why it is called controlled catalysis. Or we call this barium sulfate quinoline as catalytic poison. We call it as catalytic poison. Sir. Yes, sir. Yes, sir. Hmm. 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 Yes, sir. From your branch also they give Invictus code. They will come under your count only, your branch count only. But actually Invictus classes are happening at Madurai 1. But they, unlike earlier, that will not be counted to Madurai 1. They will be counted to Madurai 2 only. Understood, no? Right, sir. Right, sir. So, if it is not barium sulfate quinoline, all pi bonds will be converted to single bonds. Then what I should get? Butane. Correct or not? If because of barium sulfate quinoline, it is called catalytic poison. It will not allow catalyst to show its maximum activity. It will control it. So as it is controlling, it will not undergo complete reduction, partial reduction. So reaction will stop here. Is it syn hydrogenation or not? So you got cis alkene or not? Clear? So by using Lindlar's catalyst, what you got? Alkynes converted to cis alkenes. Both hydrogens are added on same side. Reaction is a controlled hydrogenation. It will not show complete hydrogenation. If I don't have barium sulfate quinoline, that pi bond also will be gone. Is it clear? Right? Now, I have taken barium sulfate. If a quinoline is not there, only I am taking barium sulfate. Right? Now, instead of reducing alkynes, I am reducing acid halides. RCOCl means acid halides. Now I am reducing acid halides, CH3COCl to aldehyde, CH3CHO. Means what happened? Chlorine is replaced by hydrogen. Acid halide converted to aldehyde. Then it is called Rosenman reduction. Observe the difference. Don't get confused between both. This is Rosenman reduction. That is a Lindlar's catalyst. If a quinoline I have taken, then it is Lindlar. If a quinoline is not there, then Rosenman. But Rosenman reduction is specialist for converting acid halides to aldehydes. Lindlar's catalyst is used to convert alkynes to cis alkenes. No confusion, right? Online response, sir.
Yes, sir.
So palladium, barium sulfate, sulfur boiling with xylene. They have taken solvent also, but they have not taken quinoline. Clear? So palladium, barium sulfate, sulfur boiling xylene. Let me take that also. Sulfur boiling xylene. What is xylene? This is called orthoxylene or not? If you have only one methyl group, toluene. If you have two methyl, xylene, orthoxylene, metaxylene, paraxylene, right? So what they have taken? They have taken xylene only, boiling xylene. Clear? No confusion now. So I'm writing the same. Boiling xylene. Generally, we'll take orthoxylene. Then we call it as Rosenman reaction. Is there any questions online? Response, sir. Response, sir.
No, sir.
Sir.
No. Sir, here you have done syn hydrogenation. Yes, yes. If I want to do anti-hydrogenation, means what do you mean by anti-hydrogenation? Here both hydrogens are added on same side. Instead, if I want to add hydrogen one below, one above, then I have to go for Birch reduction. Birch reduction. Here also I will go for non-terminal alkynes. It should be a non-terminal alkyne. Means a triple bond should not be present at any end. Right? It should be non-terminal alkyne. If it is allowed to react with blue color solution of sodium in presence of liquid ammonia, then you will get anti-addition. It is also controlled reduction or not? It is also controlled, right? There it is a cis, you got trans here. That's all. Very simple. Right? Both are hydrogenations only. Controlled hydrogenation. Any questions, sir? Response, sir. Do you have any questions in this? Online, respond.
No questions.
Means we are done with Rosenman reduction. Clear? Now I am going to next point. Reduction of nitriles. Reduction of nitriles means cyanides, right? So just go for break, come back, join in the next link, sir. Right? We will continue.
Sir, this is 11th revision.
No. It is class 12th boards.
Okay.
Hmm. Yes, sir. Yes, sir. First 58 students joined. Then it became 40. Then it became 38. Now it is 14. Hmm? So sincere students. And they will claim that we are not able to understand. If you come to classes first, you will understand. Hmm? You don't come to classes and you simply say we are not understanding. What we will do? Neither parents will not understand, no one will understand. Online. Whether they will join or not. Now it came up to 21. No, they are fooling parents only. Hmm. Parents will feel that they are sitting in front of mobile or laptop, they are listening to class.
I think
Hmm?
I told in SW0 on PTM to every parent.
Hmm.
You also check from your side whether your kid is watching class or something. Is he really reading or like?
In my career beginning, I used to hit them, sir.
Uh,
Now, from last of 7 years, 8 years, I am not uttering my mouth. 2007 to 2014, if they don't attend class, they can't even sleep. Even in dreams, I will come. Right? Literally, I used to hit you like anything. Right? Next day, if student will not come to class, parent will bring him to class and he will say, yesterday you hit him, that's why he is not there. Today also you hit him. They used to do it. Later, slowly, outside society is changing. That's why earlier I used to make girls also to stand on the desk. Here also in Akash also I have done 2 years back. I have not stopped scolding, stopped hitting, but slowly started giving small punishments. Last year and this year, I stopped that also. Oh, your super seniors, I used to make them to stand on desk. No difference between boy or girl. If you are absent to class, I used to take generally 3 hours class. 3 hours you need to stand there. If it is down now, you can adjust some, go back, come forward, something. But on desk, it will be pain only. You can't move anywhere. Later, I stopped all this. Your wish. If you study, good. If you don't study, your problem. Why I have to do? At home also, if you go punishments, my own kids are not accepting. Then how you will accept? That's why I stopped doing that. Earlier, I used to give homework. First moment, gate pass. I will check the homework. If not there, you have to stand there only. You have seen your seniors also, no? Standing outside the door. You have not seen. No, last year also I have not done that. Correct. They have to stand in the corridor, that's all. So by standing in the and again condition. Today's class notes also you should not miss. They will stand outside the corridor, they will watch in mobile and they will write the notes again. If they miss, again they have to stand outside only. Because of me only, most of the people used to left outs only. Later, our management also started asking me, because of you, many left outs are coming. You don't do it. Then I said, okay, thank you. I will not do it. Please. Not my problem. Correct? Now 33. Okay, then I will start. Reduction of cyanides, sir. See this? Cyanide with what they have given? Al, I, Bu twice. So what is it? Di-isobutyl aluminum hydride. So I am writing that. Correct. 1 minute. Why I am not able to write? Di-isobutyl aluminum hydride. Di-isobutyl aluminum hydride. We call it as a diball H, reducing agent, right? Lithium aluminum hydride, LiAlH4. This is also aluminum hydride only. This is also aluminum hydride only. Hydrogen is present over aluminum. Here also hydrogen is present over aluminum. Here more hydrogen is present over aluminum. There one hydrogen only present. As more hydrogens are present, it is a good reducing agent. It will reduce completely. Right? So if it is a triple bond, you will get single bond. So what should be product? Amine. It will convert into RCH2 NH2. If it is lithium aluminum hydride, complete reduction. If it is dibol H, diisobutyl aluminum hydride, no, will not reduce completely, partially. So instead of two double bonds, two pi bonds, only one pi bond will be reduced. So what will be that? R CH double bond ENH. Right? Partial reduction. After that, what you are doing in second step? Water, hydrolysis. When you do hydrolysis, you will break this, add OH this side, H this side. Two bonds are there. So two times I will break. Again OH, again H. So then what happens? This will convert to ammonia. Correct? This will convert to R, COH or CHOR. And on CH, you will have two OH groups. If there are two OH groups, H2O will be eliminated. So what you got? Aldehyde. That's what they have written, aldehyde. Is it clear? Any questions in it? So, if it is lithium aluminum hydride, so let me write that point. Let me write that point here. Reduction of nitrile group, CN groups. Okay, nitrile groups. So here, let me give one more idea. If it is RC triple bond N, if I do hydrolysis, if I am adding water, then how many times I have to add OH and H? And when there is bond between carbon and nitrogen, if I do hydrolysis, add OH to carbon, add H to nitrogen. Here, how many times I have to do that? 3 times. So if I add 3 times OH on carbon, what do you get? Carboxylic acid. If I add 2 times, aldehyde. If it add 1 time, alcohol. Clear? So what you should get? R COOH acid, and this will convert to amine. Right? These two may also react and lose water. Then what you may get? Amide. Are you able to understand? That's why what they will do is sometimes they will write like this: equilibrium reaction to form amide, which will undergo further to form ammonium acetate, which may further form acid and ammonia. Is it clear? First, partial hydrolysis to form amide, then complete hydrolysis to form ammonium acetate. RCO, carboxylic acid can use H plus. No? If it loses H plus, it can form RCOO minus. So RCOO minus and H4 plus. That's what we. Right? Any questions? If I do hydrolysis, instead of hydrolysis, if I am doing reduction, RCN with lithium aluminum hydride, hydrolysis, reduction, then what I should get? RCH2 NH2, amine. If it is RC triple bond N with dibol H, diisobutyl aluminum hydride, then what I should get? RCH double bond NH. After that, I am doing hydrolysis. In second step, I am doing hydrolysis. Then what I should do? What should happen? This bond I have to break. I have to add OH 2 times. Then what you will get? RCH, OH, OH. Correct? If you have 2 OH groups on same carbon, H2O is lost. Then what you should get? Aldehyde. And this will convert into NH, ammonia. So directly what we are writing? Directly we are writing aldehyde plus ammonia. Clear? Any questions about this first reaction? This one? Done? So cyanides with the dibol H followed by hydrolysis gives aldehydes. Now come to second. What is it? Grignard reagent in terms of dry ether. Right? Now what happens here? By using Grignard reagent. R C triple bond N. I am writing Grignard reagent CH3 Mg Br. What we discussed about Grignard reagent? All Grignard reagents are good sources of R minus. Or CH3 Mg Br is good source of CH3 minus. R Mg Br is good source of R minus. Now this R minus will go and attack over carbon. Then what you should get? R C CH3 double bond NH or N minus Mg plus Br. Correct? Now I am doing hydrolysis. What happened on hydrolysis? Again, this will break. Right? If it breaks, I have to add OH this side, H that side. R C double bond O CH3, correct? Plus this will convert into Mg Br NH2. Respond, sir. What you got? Again, aldehyde and ketone. Correct? That's what they are saying. Check. They added R prime Mg Br. That's why you got R prime group over carbon. Clear? Any questions, sir, about this one? Second reaction. Respond. Online.
No doubts.
Now come to next one. We are doing reduction. That in terms of SnCl2 and HCl. Observe there, sir. Instead of SnCl2, see this one. I am taking cyanide. If I am using iron in presence of HCl or tin in presence of HCl, complete reduction. Or lithium aluminum hydride. Or lithium aluminum hydride. Complete reduction. Or if I take hydrogen in presence of nickel. Hydrogen in presence of palladized carbon. Complete reduction. What happens if I do complete reduction? What happens? If a complete reduction happens, what happens? CH2, ENH2. What do you got? Amine. Correct? Among these two, iron in presence of HCl is better than SN in presence of HCl for reduction. Iron is better than tin. This is complete reduction. Right? Now what I'm doing is, instead of taking SN in presence of here, SN is in 0 state. Will react with HCl to form SnCl4 plus 4 nascent hydrogens. Very good reducing agent. Or tin plus 4 state is more stable. Correct? Lead plus 2 stable is more plus 2 state is more stable. Right? What do we call inert pair effect? Carbon, silicon, germanium, tin, lead. 4th group family, na? 4th group element generally show plus 4 state as stable state. Due to inert pair effect, lead shows plus 2 more stable than plus 4. So tin shows plus 4, obviously. Right? Now coming to this. Same cyano. If I am reducing by using SnCl2 in presence of HCl, means here what is the N factor? 2 only. Already tin is in plus 2 state. It will convert up to plus 4. So it will convert into SnCl4 plus 2 hydrogens only. Na? If it is Sn in presence of HCl, it will convert into SnCl4 and 4 nascent hydrogen. Because of 4 nascent hydrogens, it will do complete reduction. Because of 2 nascent hydrogens, it will do partial reduction. So what should they product? What should be the product now? You will get CH double bond NH followed by hydrolysis. What do you get? Oh, aldehyde. Correct or not? Correct? Any questions about this one? SnCl2 in terms of HCl. Right. Here, what is the byproduct? What is the byproduct? Ammonia is coming out. That ammonia will combine with HCl to form. Right. Here you will get ammonia also, no? That ammonia will combine with HCl to form ammonium chloride. That's what they have given the other product. Any questions? Respond. Do you have any doubt about this third reaction?
No, sir.
Sir, can you show that reaction, sir?
Yes, serious. Clear?
Yes, sir. I noted down, sir.
No. See this statement, sir. I am taking the side heading. Stephen reduction. I am typing it as. Where is it? Stephen reduction. What is it, Stephen reduction? Same or not? Correct or not? Cyanides in presence of SnCl2, HCl followed by hydrolysis. What you got? Aldehydes. So what we call them as? What do we call them as? Stephen reduction. Correct? Means what is this reaction called as? This is the third reaction. We call it as Stephen reduction. Any questions? Clear? No. One more point. Mendius. Mendius reduction. Oh, sorry. You asked the Mendius, it is showing something as this one. It is also what? Cyanides are reduced to amines, but by using sodium in presence of ethyl alcohol. Right? So let me write that again. Here, same thing. Here, same cyanobenzene is reduced in presence of sodium and ethyl alcohol. Then also I will get same. But we call this as Mendius. Any questions? Online, someone respond, sir. If by using lithium aluminum hydride also, you will get amines. Sodium in presence of ethyl alcohol also, I get amines, but we call that as Mendius reaction or Mendius reduction. Clear? Response or online.
Yes, sir.
Observe the difference between Mendius and what is the second reduction? Stephen. Stephen reduction, Mendius reduction. In Mendius reduction, you will get amines. In Stephen reduction, you got aldehyde. Clear? Now come back. So all these three are done. Now I am coming to next one. What is it? Reduction of esters. Again, what you have used? Dibal H only. Here also dibal H only, no? Diisobutyl aluminum hydride, followed by heating, followed by hydrolysis. So esters are converted to aldehydes. Right? So I'm writing the same. Reduction of esters. Reduction of esters. So R CO O CH3 in presence of diisobutyl aluminum hydride, dibal H, followed by hydrolysis. Then what you will get? You will get aldehydes, plus this will convert into alcohol. We call it as reduction by using diisobutyl aluminum hydride, reduction of esters to aldehydes, right? So dibal is a specialist for reducing esters to aldehydes. Of course, we can use hydrogen pentapalladized carbon also. To reduce esters to aldehydes, I can use hydrogen pentapalladium also, palladized carbon, right? H2 in terms of PDC, palladized carbon also I can use. The same ester, if it is reduced by using sodium in terms of ethanol, sodium in terms of ethanol alcohol also reducing agent, right? Then we call it as, observe this, Boviet-Blanc reduction. What is Boviet-Blanc reduction? Esters reduced in terms of sodium ethyl alcohol to form alcohols. What we call it as Boviet-Blanc reduction. So I'm repeating again. Same ester RCOOCH3. If I am reducing by using sodium in presence of ethyl alcohol, then it will convert into RCH2OH, and that also converts to ethanol. Then we call this as Boviet-Blanc reduction. Right? Same cyanide is reduced by using sodium ethyl alcohol. If it is cyanide reduced by sodium ethyl alcohol, Mendius. Ester reduced by sodium ethyl alcohol, Boviet-Blanc. No confusion, right? Here you got alcohol. Above case you got aldehyde. If it is reduced by using dibal, you will get aldehyde. If it is reduced by using sodium ethyl alcohol, you got alcohols. Any questions, sir? Respond.
No, sir.
Means, are we done with this reaction also? Formation of aldehydes from esters. Done. Now see this next one. Getterman-Koch aldehyde synthesis. What do we call it as? Gatterman-Koch aldehyde synthesis. Benzene allowed to react with carbon monoxide in presence of HCl and AlCl3 acts as a catalyst, right? Then this CO acts as electrophile. But actually it exists like this, right? This is carbon monoxide, right? Now, if I make these electrons to come back over oxygen, now it becomes electron deficient. Carbon monoxide acts as electron deficient. When this oxygen donated lone pair, then only it will become like this. We get partial negative over carbon, partial positive over oxygen. Carbon monoxide, which acts as a donor. Carbon monoxide acts as a ligand or not? Lone pair electron donor. Which will donate, oxygen or carbon? Which is rich in electrons, man, carbon and oxygen. See the second case. So always it is a carbon monoxide, always a monodentate ligand. Always carbon acts as a donor. Right? Oxygen becomes electron deficient because of donating that lone pair electrons into empty orbital of carbon, covalent and covalent bond is formed. That's why carbon becomes rich, oxygen becomes deficient. That's why always carbon acts as a donor. It is a monodentate ligand. It is not ambidentate ligand. Monodentate ligand. Only carbon will donate always. Carbon monoxide. Right. Now, do carbon acts as electrophile or not? It becomes electron deficient if I remove the third bond, covalent and covalent bond. Now it will go and attack over benzene. If it attacks over benzene, what happens? Into this empty orbital, this pi bond is donated, forming positive bond carbon, double bond O. Right? So it get donated, electron deficiency of carbon is gone. Now this is positive, you have hydrogen. Now what happens? This bond will shift here and this H goes here. So then what you will get? Clear? So we call this as Gatterman-Koch. Benzene with carbon monoxide, HCl, CuCl, AlCl3, anhydrous AlCl3. So benzene will convert into aldehyde. So we call it as Gatterman-Koch. Any questions are in Gatterman-Koch? Respond.
No questions.
No,
sir.
sir.
So here which acts as electrophile? CO acts as electrophile. Now observe Friedel-Crafts alkylation. Almost the same. Here what happened? We are taking acid halide CH3COCl in presence of AlCl3. These two will combine to form AlCl4 minus, and this will convert into CH3CO plus. Now CH3CO plus acts as electrophile, that will go and attack. Then you got ketone. Correct? If it is carbon monoxide, I got aldehyde. If it is RCO group, you got keto group. So we got as Friedel-Crafts acylation. Instead of acyl group, if it is CH3 plus, then it is called Friedel-Crafts alkylation. Friedel-Crafts acylation, Friedel-Crafts alkylation. Any questions? Respond. Do you have any questions, sir?
No questions.
Now come to next one. Clear all? Now, observe the next one. Preparation of aldehydes or ketones from alkyls. Now let us come to this. I am taking from alkyls. CH3, C triple bond, CH, alkyne. Allowed to react with HgOAc twice in presence of H2SO4, followed by reaction with sodium borohydride NaBH4 in presence of H2O. We call this as oxymercuration demercuration reaction. Oxymercuration demercuration reaction. Oxymercuration demercuration. Now what happens first? Mercuric acetate will go and attack over triple bond. Then it forms CH3, C, double bond C, H, Hg, OAC. One OAC is gone, so you got positive charge. That positive charge pulls the electron cloud of this pi bond, forming a three-membered cyclic transition state. Hg plus will go and attack over the triple bond, forming a partial electron cloud, three-membered ring. Now, water will donate electron cloud to the more substituted carbon. As water donates more electron cloud, lone pair electron cloud, it will convert into CH3, COH, double bond, CH, Hg, OAC. When water donated lone pair electrons here, this bond will go down. Right? Now, this with the sodium borohydride, NaBH4 also you are adding. Right? So it will rearrange, forming CH3, COH, double bond CH2. And what is gone means? Hg is gone. ACOH is also gone. Or I will write ACO minus also gone. Acetyl group gone, mercury gone, remaining group we got hydrogen. Now it tautomerizes. During tautomerism, what happens? This bond will shift, that hydrogen comes here. So it will convert into CH3, C double bond O, CH. Clear? Now, while I am adding water, observe overall what happened. Here OH group, here H group got added, na? Indirectly. Now OH group got added to more substituted carbon or less substituted carbon? This is acetylene, ma'am. This is acetylene. In this acetylene, where we are adding OH to middle carbon or last carbon? Middle carbon. Means I am adding CH3, C double bond. Instead of one more bond, I am adding OH here. Here I am adding H. Correct? Huh? Right? So indirectly I am adding water. That's why it is called hydration. Addition of H2O. Hydration. So here OH got added to more substituted carbon. That's why it is called Markovnikov addition. Earlier, someone asked me about this Markovnikov. Respond. Yes or no? That fellow is not there. Huh? Maybe he is not here. Okay. Here, OH group gone to more substituted carbon. That's why it is Markovnikov addition reaction. OH and H got added in opposite direction. That's why I call it as anti-addition. Right? No, don't think much about it. Markovnikov, that to that extent it is accurate. Now, if I take the same reagent, instead of oxymercuration, demercuration, first I'm adding boron hydrate or diborane in terms of tetrahydrofuran solvent, followed by peroxide, any peroxide in terms of base. We call it as hydroboration oxidation reaction. We call it as hydroboration oxidation, HBO reaction. Hydroboration oxidation reaction. Right? In both cases, what you are adding? In both cases, I am adding H2O only. That's why both are examples of hydration reactions, means addition of water. But in HBO reaction, what happened means, in HBO reaction, OH got added to less substituted carbon and H gone to more substituted carbon. Are you able to understand? Now, oxymercuration, demercuration, OH is coming on more substituted carbon. In HBO reaction, OH goes to less substituted carbon. Of course, here there is a triple bond, no? So I need to do like this. So H here, double bond, CH, OH. So is it Marconi or anti-Marconi? Or negative part gone to less substituted carbon, na? So this is anti-Marconi coupler. Now again it automerizes. Product will be done. So above case you got ketone. Now I got aldehyde. In both cases, reactant is same. In oxymercuration, demercuration, OH gone to more substituted carbon. In HPO reaction, OH gone to less substituted carbon. You got aldehyde, ketone. Correct? Any question? Both are examples of hydration reactions. Now see this, whether we have done with those two examples or not. This is oxymercuration, demercuration, and this is hydroboration, oxidation, HBO reaction. Any questions about this one, sir? Do this is done or not? Do you have any questions?
No, sir.
Right? Now I am coming to next one. Response, sir. Clear or not? Now I am talking about next one. Oxidation of 1,2 glycols. Oxidation of 1,2 glycols. I am coming to that. 1,2 glycols means OH groups are adjacent carbons. If OH groups are on same carbon, then it is called geminal. If it is on adjacent carbons, we call it as vicinal. Right? So CH2OH, CH2OH. Is it vicinal or not? Vicinal. So vicinal diol. Correct? This on oxidation with lead acetate or HiO4. In both cases, if we have oxygen on adjacent carbons, that carbon-carbon bond will break. If this carbon is having oxygen, below carbon also having oxygen, then CC bond will break. And this will be oxidized, the below one also will be oxidized. So what do you get here? Above carbon converts to aldehyde, below carbon also converts to aldehyde. So what I got? 2 moles of aldehyde. Right? What we call this HiO4 as periodate. Clear? Are we done with this reaction or not? Check. 2 OH groups on adjacent carbons. We are using lead acetate or HiO4. In both cases, what happens? CC bond will break. If CC bond will break, this will convert into aldehyde, that also converted to aldehyde. Right? They have taken lead tetraacetate. Of course, I have taken lead diacetate. Let us take this also as lead tetraacetate. No issue. We also call it as sweet syrup. This is also called as sweet syrup. This is the reagent which killed all Greeks. Alexander the Great. If they are not affected by this, he might have conquered total Asian continent. Only because of this, he lost everything. You know it or not? Similarly, Napoleon. Napoleon also defeated by only one metal, tin. No one is able to win above on Napoleon. Tin metal declared war on Napoleon. Because of tin metal, he lost. Right? Hitler is lost because of only one thing. What is it? people's car. Oaks wagon. Oaks people, wagon means car. People's car. Volkswagen company, man. Because of this, Hitler also lost. You know it or not? Volkswagen is nothing but from Germany, man. Hmm? See, this Alexander means far back. This technology is not there, right? Distillation process, preparing ethyl alcohol, this much evolution not happened, right? What they used to do is rotten fruit juice. They used to boil, right? Then they used to filter. Remaining thing they used to consume. So they get that, what we call it as a kick, what you call. So they used to drink it. Fermentation, correct? Fermentation, they used to do it and they used to boil it. But it is very sour to taste. How much sour means if you swallow, your skin on your tongue and mouth will peel off. Acid, na? Correct? Or tartaric acid in tamarind. Same way in grapes, what it is? Where also I think it is rich in tartaric acid. Tomatoes are rich in oxalic acid. Right? Now, so it is rich, it is acidic. That's why when you are consuming, it will destroy your, what we call it as epidermis or whatever dermis or whatever the layer over the skin. So you will get burning sensation. So next day you will have to suffer. But they want to drink. So what they used to do is their shields, armor shields, are made up of lead. So while they are boiling it, they used to cut a piece of it and they used to boil it. So lead reacts with acids to form lead tetraacetate. It is called sweet syrup. The same lead tetraacetate we are using in packaged food materials even now. Noodles. If you eat that raw noodles, you will have not completely sweet, slight sweetish nature, like rice, right? That is because of lead tetraacetate. If it crosses certain limit, then it is poisonous. That's why I think after the time of Corona, they banned Nestle products because they are rich in lead tetraacetate. That's why the company, Nestle's company, noodle packets has been banned. Then Tata started producing it. Now, after a few days, everyone forgot. Then it came to market again, right? Because of lead tetraacetate. It is called sweet syrup. So they used to boil it by using lead tetraacetate and they used to consume. But lead is heavy metal poisoning. Because of heavy metal poisoning, they already dead. No need to die in war. They are already dead only. Dead man walking. Dead man going to war. Right? No. Due to heavy metal poisoning, they are gone. Now coming to Napoleon. When he marched 20,000 soldiers into Russia, you know, in Russian climatic conditions, at one end, it is too hot. At the other end, it is too cold. Right? So that, and it is so vast country, different time zones, different climatic conditions. So Napoleon, this foolish fellow, he made this war declaration, particularly during winter season. He might have waited for some more time, right? With 20,000 soldiers. It is not a small army, it is a big army. Lead has a property. All these armors, armored men's, means armed soldiers, dress code, these buttons, all these are made up of tin metal, shiny metal, right? This tin, when temperature drops down, it loses its crystalline property and becomes amorphous. Becomes so brittle and converts into amorphous, means becomes powder. So when they are marching into Russia, as temperature is low, all this tin metal converted into powder. So they are busy in holding clothes. It is winter. If clothes are not there, they will die. So, because to survive from weather, they are trying to hold their clothes. Then who will shoot them? Obviously, Russians are very much aware of it. They killed all 20,000 soldiers. Means not all. Hardly, I think, 1,200 to 1,300 soldiers returned back. Remaining all army is gone. That's why Napoleon lost the war. So, which metal helped Russia? Tin. Because of tin, he lost the war. Same way, because of lead, Alexander is also gone. So, Alexander's guru, Aristotle. Aristotle's guru, Plato. Plato's guru, Socrates. What, man? They are very famous, man. Greek philosophers. Okay, leave it, leave it, leave it, leave it. Anything else I am saying? This Volkswagen. He started that company with a beautiful concept. Car should be available to common man. This is the idea. Because of it, he got huge people support in his country. That's why everyone want to participate in war. That's why Hitler keep on winning the wars. Most of the wars he won. Only one war he lost. Last war. Right? So once he started, everything gone well. After a certain extent, instead of producing cars, he started producing armored vehicles. So that company, instead of producing cars, it started producing armored vehicles, man. Means what we call tanks, right? So what happened? Production costs raised. Funding is done by government. So people have to suffer by paying taxes. Happiness ratio, happiness index gone down. Revolution started, civil revolution started in Germany also, because major source is food. Survival is the first thing. Later, after survival, if you are survival, then you will fight. So your survival itself became difficult. He ordered food from, means purchased food grains from other countries. That shipment has been blocked by America. So when the shipment doesn't reach Germany, people has to starve. So any human can be cautious for everything, but not for hunger. You will accept everything, but not with hunger. So that is the primary source of any revolution. That's destroyed Hitler because of one wrong idea. He might have not done that. Of course, there are some other reasons also going into Russia. Russia combined with one side America has blocked, the another side Russia started invading. Japan also participated. They are not so much successful. There are many other reasons, of course. Right? So this is also one of the reasons. Okay, leave it. Leave it. Leave it. Now let tetraisolate or HiO4. What they will do? They will break carbon-carbon bond if carbons are connected to oxygens. Any questions about this reaction now? Do you have any questions about this? Right? Now coming back. Itard reaction. Where we have seen this CrO2Cl2, sir. Where we have seen this? Chromyl chloride. Chromyl chloride test. A test for ionizable chlorides, NaCl, KCl, right? When they are ionizable chlorides, means where Cl minus is available freely. When you add K2Cr2O7 in presence of acidic medium, it will convert into reddish vapors, CrO2Cl2. We call it as chromyl chloride. On adding sodium hydroxide, it will convert into Na2CrO4, yellow color solution. On adding lead acetate, it will convert into PbCrO4, yellow color precipitate, confirms presence of Cl minus ions. We call it as chromyl chloride test. I'm repeating again. If we have free Cl minus ions, any reagent having Cl minus ion, if it is allowed to react with either Na2CrO4 or K2Cr2O7 in presence of acid, then this will convert into CrO2Cl2, chromyl chloride. Reddish vapors. This, when reacted with sodium hydroxide, converts into Na2CrO4, yellow color solution. This, when allowed to react with lead acetate, it converts into PbCrO4, yellow PPT. Observation of yellow precipitate, yellow solution, and red color vapors all will confirm Cl minus ions. Right? This is not happens in case of Br minus and I minus. Only it is suitable for Cl minus. So identification of chloride ions. We call this test as chromyl chloride test. Obviously, it must be ionizable. That's why test fails in presence of HgCl2, PbCl2, AgCl, etc. These cases test fails. Reason? They are insoluble in water or less soluble in water. As they are less soluble in water, they cannot produce Cl minus ions. Clear? Any questions, sir? Online?
No, sir.
So,
No, sir.
by using that chromyl chloride, CrO2Cl2, of course, oxidizing agent, we are oxidizing that methyl group 2 aldehyde. We are oxidizing this methyl group 2 aldehyde. We call it as Itard reaction. Toluene, allowed to react with CrO2Cl2 in presence of carbon disulfide, followed by hydrolysis, converts to aldehyde. We call it as Itard reaction. Any questions in this? Response, or do you have any questions in this? Respond online. Say something.
No, sir.
No, sir.
Instead of that, if I take isopropyl benzene, we also call it as cumene, correct? If it is oxidized, then what you will get? Right? Hawk rearrangement, right? Or peroxy rearrangement. Now this hydrolyzed on followed by heating, what you will get? You will get phenol plus acetone. Correct? Respond. Right? Preparation of phenol from cumene. Correct? So instead of this, we have taken methyl group there. This is also oxidation or not? This is also oxidation. But here I am not breaking benzene carbon bond. Next one, sir. Chlorination. Chlorine in presence of sunlight. What happened? If it is same toluene, if the same toluene, instead of chlorine and sunlight, if I take chlorine in presence of iron, or chlorine in presence of AlCl3, or FeCl3, or ZnCl2, then what happened? Ortho para directing group, na methyl. That becomes major and this becomes minor. Electrophilic aromatic substitution. Electrophilic aromatic substitution reaction. If it is chlorine in presence of sunlight, radical substitution. Free radical substitution reaction. Means here hydrogen is replaced by chlorine. So two chlorines are there, so two hydrogens are replaced. So then what you will get? On benzene, you will get CHCl2. Then if you are adding aqueous KOH or NaOH aqueous or simply water, chlorine will be replaced by OH groups. So if two chlorines are replaced by two OH groups, what you will get? Aldehyde. Clear? Any questions are in that? Respond. Do you have any questions?
No, sir.
No, sir.
So we are done with all preparation methods of aldehydes and ketones as per your NCERT. Now coming to physical properties, just it is theory, just read it once. Lower members of aldehydes and ketones up to C10 carbons are colorless, volatile liquids, except formaldehyde. Formaldehyde is a gas at ordinary temperature. Higher members are solids with fruity smell. Right? Example, vanilla beans. Vanilla. See that one? From vanilla beans. You have aldehyde group or not? Right? Vanillin. Then salicylaldehyde. It is also from meadowsweet. That is a plant, white colored. It is not flower also. It looks like that. Right? You have that good smell. Sweet smelling. So from meadowsweet. Then cinnamaldehyde from cinnamon. It is also having some not sweet, but similar to sweet type taste. In biryani, that bark, right? Tree bark, right? Cinnamon, right? Aldehydes and ketones are widespread in plant and animal kingdom. That's what they are saying. Any questions? Is it clear about that statement? Higher members of aldehydes and ketones are solids with fruity smell, fruity odor. Lower aldehydes have unpleasant odor, but ketones possess pleasant smell. Boiling points. Boiling points of aldehydes and ketones are higher than hydrocarbons and ethers, but lower than alcohols, because alcohols form hydrogen bonding, right? Higher than hydrocarbons and ethers of comparable mass due to weak dipole moments. Next, their boiling points are lower than lower than alcohols of similar molecular mass due to absence of intermolecular hydrogen bonding. In alcohols, hydrogen bonding is there, therefore their boiling points will be high. Next, among isomeric aldehydes and ketones have slightly higher boiling point due to presence of two electron releasing alkyl groups, which make carbonyl group more polar. Then means compared to aldehydes, ketones have higher boiling point due to dipole moment. Solubility. Lower members of aldehydes and ketones are soluble in water due to hydrogen bonding, but higher members are less soluble. Means as chain length increases, solubility decreases. Aromatic aldehydes and ketones are much less soluble than corresponding aliphatic aldehydes and ketones. All carbonyl compounds are fairly soluble in organic solvents, less soluble in water, more reasonably soluble in organic solvents like CCl4, diethyl ether, etc. Any questions are up to these chemical properties? Physical properties? Do you have any questions regarding physical properties?
No, sir.
Now coming to chemical properties. Nucleophilic addition reaction. Better, I will stop today's discussion. Right? These things we will discuss in the coming class. Few important dates. I think next Thursday. Right? Again, Thursday we will discuss. Mostly by next Thursday, we will close this. Right? So I think tomorrow we have class, man. Friday and Saturday also, I think. Our regular class. Right? Where I will continue with.
Sir.
As usual. Yes, sir.
Sir, tomorrow link will be posted in app, no, WhatsApp, no, sir.
No, I will post. Today also I posted, I think so.
Sir, today it was posted, sir.
Tomorrow also I will post. Tomorrow's link also I will post. Okay. All right, sir. Shall I close the session? No one is responding. Shall I close the session?
Yes, sir.
Yes, sir.
Yes, sir.
Are you? Is it useful or it is time waste?
Useful, sir.
It's useful, sir.
Useful.
What you learned today?
I'll
Say something. What you learned?
Preparation of aldehyde, sir.
Preparation of aldehydes. Nomenclature? Nomenclature also or not?
Preparation
Sir,
of
we learned
aldehyde.
nomenclature.
Right. Right, sir. Okay, I will end the session. On every Thursday, I am repeating again. On every Thursday, whatever the things related to boards, you can raise a query. I will explain. Right? We will continue with this. If you have any other important topic or important concept you have doubt, you can ask me. I will explain. Friday, Saturday, Sunday, we will go with our regular portion. Right? After aldehydes and ketones, you tell me one more chapter. I will start with that chapter. We will discuss continuously. Simultaneously, you think that as indirectly we are doing revision for mains. Boards means nothing but mains, man. Don't think that boards means something else. Mains is something else. Indirectly, I am doing revision for JE mains. Right? Okay, sir. I will end the session. Thank you.
Thank you,
Thank you,
sir.
sir.
Thank you, sir.
Thank you, sir.
Yes, madam. Welcome. Bye. Good night.
Thank you, sir.
Bye, sir. Good night. Good night.
Thank you, sir.
Yes, sir. Good night. Bye, sir.